Out of all the plants on Earth, there are over 50,000 distinct varieties that humans can actually eat. This graphic shows what actually makes it to our plates. That massive natural buffet has shrunk down to a tiny sliver of just 15 staple crops. And if you look closely, the vast majority of our global diet relies on only three: corn, wheat, and rice. For thousands of years, farming operated like an open-source network. Farmers freely bred, saved, and traded seeds with each other, adapting crops to their local climates and cultivating this massive biological library. Today, that open exchange system is mostly gone. In the 20th century, agriculture shifted toward mass production, replacing local varieties with highly standardized, lab-made seeds designed to maximize yield. As this map of the U.S. shows, 90% of the country's corn, cotton, and soybeans are now grown using seeds that are patented property. A handful of multinational companies own the rights to the genetic code of these crops, controlling exactly what farmers grow and what we eat. The companies that own these patents, giants like Monsanto, which is now owned by Bayer, did not start out in the agricultural business. They were chemical manufacturers. Early in the 20th century, they built their fortunes refining fossil fuel byproducts into industrial materials like synthetic sweeteners and plastics. They also manufactured PCBs, a highly effective chemical insulator that was put into almost everything before it was eventually banned for being toxic. By the 1960s, they had adapted this chemical expertise for the military. During the Vietnam War, Monsanto became one of the largest suppliers of Agent Orange, spraying millions of liters of military-grade defoliants to strip away the tropical jungle cover. When the war ended, the government contracts dried up, and their industrial plastics faced strict new environmental regulations. So the company took decades of research into chemical toxins and pointed it at a new peacetime target: weeds. In the 1970s, they introduced a highly profitable herbicide called Roundup. Its active ingredient, glyphosate, was incredibly effective at killing weeds. The problem was it was so effective that if a farmer sprayed it over an entire field, it would kill their cash crop too. The company's researchers spent the next 2 decades looking for a biological workaround. In 1996, they released a genetically engineered crop called Roundup Ready. They had successfully modified the DNA of the seed so that it was completely immune to glyphosate. The genetically modified seed was a proprietary delivery mechanism. Monsanto engineered the plant's survival to be tethered to their specific brand of herbicide, turning the crop itself into a tool to ensure chemical sales. For farmers, it felt like a perfect labor-saving solution. They no longer had to mechanically till their fields to remove weeds. But to get that convenience, they had to buy the proprietary seed and the matching chemical from the exact same supplier. The biology of the fields adapted quickly. Almost immediately after these crops were introduced, the weeds began mutating and developing a natural resistance to Roundup. This chart maps out the resulting trap. To fight off these new, resistant weeds, farmers had to spray a higher volume of the herbicide. That drove further resistance, requiring even more chemicals, creating a highly profitable cycle for the manufacturer. Because the seeds are patented, farmers are legally forbidden from saving them, forced to buy new seeds and chemicals every spring. This reliance on synthetic chemicals carries a massive environmental cost. Heavy use of commercial fertilizers and pesticides drives up atmospheric levels of nitrous oxide, a greenhouse gas that trails only CO2 and methane in its contribution to climate change. Scientists who have reviewed decades of data on these engineered crops have found little evidence that they actually produce higher yields. What they have produced is the highest global application of agricultural herbicides in human history. Relying on a single, standardized crop over millions of acres creates enormous risk. When entire regions are planted with identical genetics, a single new disease or a severe drought can wipe out the entire harvest. To protect the global food supply from this vulnerability, researchers and governments are building vast agricultural archives. There are currently over 1,700 seed banks around the world, carefully storing the diverse genetics of traditional, unpatented crops. These banks treat biological diversity like critical data. In Norway, a vault built deep into the permafrost of Svalbard preserves over 1 million seed samples. A new facility in Colombia uses artificial intelligence to scan thousands of traditional bean and cassava varieties to identify genetic markers that can survive extreme conditions. The potential locked in these vaults is attracting major capital. Private investors, including Jeff Bezos' Earth Fund, have pledged tens of millions of dollars to expand these climate-resilient agricultural banks. Because these heritage varieties were naturally bred by farmers over hundreds of generations, they carry a wide array of dormant traits. Scientists in India recently found local rice strains that easily outperform commercial alternatives in flooded or salty soils, proving that our oldest seeds might be our best technology for a changing climate. The reason many of these seeds still exist today is because local communities refuse to let them die out. In places like the Malnad region of southern India, generations of women have acted as seed keepers, quietly maintaining vast collections of unique local crops in their own gardens. When local varieties are lost to commercial standardization, these archives provide a way back. The Crajo indigenous tribe in Brazil lost their traditional corn varieties after modern rice was introduced to their land. Decades later, they were able to access a national seed bank, retrieve the exact kernels their ancestors grew, and successfully return them to their fields. Restoring this diversity provides a critical safeguard against crop failure, while recovering the distinct flavors, nutrients, and deep cultural histories that get erased by an industrialized food system. Securing our future food supply requires breaking the corporate chemical loop and returning to a system where agricultural biodiversity belongs to everyone.